In our blueprint, this kind of arrow represents the materials we're using. Also, some of the other materials are labeled besides the blueprint. And for the solid arrow, it represents the movement of the ball or the simple machines, in which you can see in blueprint as the ball is being dropped down. It follows the path of the inclined plane and drops into the cup of the pulley. Then the left side of the pulley will get lower. Then the right side of the pulley connects to a plastic cardboard will be lifted up. And as the cardboard is being released, the ball again follows the path of the inclined plane until it drops into the ball on the right side of the lever. And as this side is being heavier, it becomes lower, which is the same theory as the pulley. As it becomes lower, the left side will be lifted. We connected the left side with a cardboard using yarn, and so if this lifts up, the cardboard will be pulled out, which is being released, so the third ball will be rolling down the inclined plane again. So as it rolls into the cup on the right side of the pulley, the right side becomes lower again, the left side becomes higher, and these cardboard bricks would lift the inner side of the cup. Then the ball in the cup would roll out, and as it hits the fidget spinner, which is more like a decoration, it traveled to the next inclined plane, then to the last part of our machine, which is wheel and axle. We used the axle in the middle of the fidget spinner to be our axle for this part. So as the ball hits a little piece of cardboard right here, the cup starts to turn like a little fan. Then the water in the cup could successfully powered out. As you can see, energy transfer are also labeled in this blueprint, which we will be explaining later on with our real machine. Lastly, for the calculation of gravitational potential energy, kinetic energy, acceleration, and velocity are all involved in this blueprint too. We calculated these energies in the entire machine. However, we didn't calculate the pulley, lever, and wheel and axle. We did research online, but it didn't show how to calculate these energies specifically. Also, for the velocity, only using the video checking the time is really inaccurate. It only takes about 0.01 second or even faster to make the simple machine works. So this may result in 0 in all energies, or at least 2. But it is impossible to have 0 joules of energy and the object is still moving. So we eventually cancelled the calculation of lever, pulley, and wheel and axle. This blueprint is a bit small, so there's only results of each part for each energy. Let's see the detailed calculation. Zoom in this part. Using this as an example, these are the dimensions and basic information. We calculated the velocity first because velocity involved in most of the calculations, but we didn't follow the original formula, which is distance divided by time, because the time is a bit inaccurate. So we use another way. We think that because of mass times gravity times difference in height always equals to half times mass times velocity squared. So the velocity will equal to this. Yes. And we fill the numbers above into this, into the variables. We will get a result of approximately 1 meter per second. Then, calculating all the other energy and acceleration, using the formula mass times gravity times height, we get a result of 15.78 joules. And thirdly, calculating the kinetic energy, again using the formula right here, we get a result of 11.5 joules. Lastly, calculating the acceleration, the final velocity minus the initial velocity divided by the time, will get a result of 1 meter per second squared, which is the same, which the only number is the same as the velocity, but the units are different. So all the other parts of calculations are using the same theory as well, so I'm not going to analyze each of them in this video, but you can see the detail of each part in the next few seconds.
Hello everybody, so today we'll be introducing our Rube Goldberg machine. The objective of our machine is to water a plant, which is down here, as you can see. And our machine uses several simple machines, such as inclined planes, pulleys, lever, and a wheel and axle. So this is how our machine will work. First, we use this imaginary marble here. We drop the ball manually here, and as it runs down the inclined plane, it falls into the cup. And with the weight pressuring the cup would cause this pulley to function and then suck away at this little thing. And that was this little thing right here. It was supposed to block this another marble, small one, from running down these inclined planes. So since this is gone, the marble starts running down the inclined planes, and then as it reaches here, the lever, and as it falls into the cup, it causes this little door thing, I guess, and it's like it kind of sucks it away. And this little door was supposed to block another marble from running down here. So now this is gone, the marble is free to go. Okay, so as it runs down, it falls into another pulley. So falling into another pulley, well, in this case it doesn't work like really like a pulley. In this case it works more like kind of like an elevator, like a transition. And then so it falls into the cup, and with the weight of the ball pressuring the cup falls, and takes the ball and takes it like here, and then it falls out of the cup, and then it hits a fidget spinner, which would bring it down here, and then lastly it falls into this cup, which would have water filled inside it, and then it falls into the cup with the weight pressuring a cup. Again, the cup is going to fall, and then lastly, just pour the water on the cup.
Yay! Here 没有。
Oh no, I'm gonna be away for 5 days and nobody's gonna be watering my plants. What do I do?
Let's introduce our water plant machine.
This machine is cheap, definitely eco-friendly, and efficient. It only takes 24 hours to build and another 24 hours to test. All you have to do is drop marble.
Wow, now my plants are gonna be safe and healthy when I return from my trip.
Call 0800 078 7878. Call now for buy one get 10 free. Only if you call now.